So, spiral 2. So the first question is if determinant phi minus 3 is negative, 0, or positive, and explain why. So let's start with identifying my components. So C is minus 3, and then C, it's this tiny, and I'm going to put it over here right there. That's how big C is, and that's the size of C, right? The absolute value. That's the absolute value. Just it's telling you what the size is, right? It's whether it's positive or negative. We'll talk about that later in a second. But C is that size, and let's identify that's negative. Minus 3, and 3, according to that number line, is this big, right? And that number 3 as it stands is positive right now. Well, let's change this to an addition. If I change this to an addition, well, that C stays as C. It's still a negative. The subtraction, we're going to change it to addition. And the additive inverse of that 3 positive, right, the size stays the same, but now it's a negative, right? So it's a negative plus a negative, which, think about it, when you add two negatives, you're going further left on the number line, right? So what am I doing with these two absolute values? I'm actually joining them. So here's C, and right next to it, I'm going to put 3, right? So whatever C is, it doesn't matter what it is. So the answer is 3 plus C, and 3 plus C, actually, because we're adding two negatives, it's just a negative that's further left on the number line. So I added the absolute value of C, right, the size of C, to the absolute value of 3. And because both are negative, right, they went, that their sum, in this case, their sum ended up being their combined distance further left, right, their combined absolute values further left of 0 on the number line. Okay, so again, what do we do with their absolute values? We combine them, right? We added the absolute value of C plus the absolute value of 3, and their sum, right, their combined absolute values, was the answer to this question. Okay, so the answer is negative. What's next? Change it to what? All right, so this one, the 1 is repeating, so we're going to say that x equals 104.1 bar notation. We're going to multiply both sides by, again, remember what 104, 1, 1, 1, 1, 1, and that, that's what that looks like. And if I multiply that 10, it's going to go, the value is going to increase 10 times, and the little trick we do is just move the decimal 1 over. There you go. Right, so we multiply both sides by 10. If I multiply x by 10, I get 10x. Just like I did right now, if I multiply 104.1 bar notation times 10, I get 1,041 bar notation. 1 bar notation. What do we do now? We subtract both values. 10x minus x is 9x. If I subtract this, the repeating parts can go away, and 1041 minus 104, was it 1041 minus 104 is 937. Yeah, divide both sides by 9, and x equals 937 over 9. If, again, you want to change it to a mixed number, you can. We don't have to right now. Okay, so that's that. The second one, 2.345. Again, let's look at that. 345, 345, 345. That's what that looks like, right? So x equals 2.345 bar notation. We're going to multiply that by 1,000, right? Because multiplying by 1,000 is going to move this decimal 3 places to the right. So my answer, once you multiply these two, is going to be 2345 dot 345, 345, 345, etc. Okay, so multiply both sides by 1,000. 1,000 times x is 1,000x. On this side, 2.345 times 1,000 is 2,345.345 bar notation. That allows us to subtract. 1,000x minus x is 999x. If you subtract 2,345 and 345 thousandths are repeated, right? This repeating part and this repeating part will eliminate each other, and then 2,345 minus 2 is 2,343. Divide both sides by 999. X equals 2,343 over 999. Can we divide by 3? This is 5. 5 and 6. No, it's not divisible by 3. So you might as well just leave your answer. And if you want to take your calculator and plug in 2,343 divided by 999, you'll notice that you get this number right here. Okay, so that's one nice way of checking your answer. Okay, the 3 is telling everybody inside the parentheses to multiply by itself. So let me rewrite this in standard notation. So this is what that equals to. Right, so we have, and then including this negative sign outside, we have 4 negative signs. So that's all just going to be one big positive, right? Which I didn't need to write, but just to let you know. And then 2 times 2 times 2 is just 8. So that all is positive 8. Find the nth term. Uh-oh. Right, so 1, 5, 9, 13, 17. Take the first difference. This is plus 4, plus 4, plus 4, plus 4. So this one is easy, right? So it's a what do you call a linear sequence. So it's going to be a 4n sequence, right? So it's going plus 4, plus 4, plus 4. What else goes plus 4, plus 4? Well, the 4 times table. So let's plug in this. Let's replace with n. Let's replace n with the first, this 1, 2, 3, 4, 5, and get the first 4 terms of a 4n sequence. So 4 times 1 is 4, 4 times 2 is 8, 12, 16, and 20. Okay, so now we don't want 4, 8, 12, 16, 20. We actually want 1, 5, 19, 30. So how do I adjust this sequence? What adjustments do I make this sequence to give me the original sequence giving to us? Well, remember I told you we can subtract, right? Just 1 minus 4 is negative 3, 5 minus 8. So you notice that it's minus 3, minus 3, minus 3. So our sequence ends up being 4n minus 3. So that's the nth term here. Just double check. Let's pick this one, the 5th number, the 5th term. So when n equals 5, we should get 17. Do we get that? 4 times 5 is 20, minus 3, 17. Yeah, we're good. Prove that a negative by a negative is a positive using this tree property. Okay, so how do we do this? So let's pick negative 5 times, let me find something here. Negative 5, times 0 equals, you know that, 0. I'm going to replace this 0 over here, this 0 over here, and I'm going to write negative 5 times, let's pick something that equals 0. 3 plus negative 3. Okay, equals 0. Well, I still kept the equation true. 3 plus negative 3 is 0. So far, I haven't done anything. I just rewrote 0 as 3 plus negative 3. Now, let's use this tree property. Now, I know negative 5 times 3 is negative 15, right? Because I can make 3 groups of negative 5, and I have a negative 5 times negative 5 times negative 5, and that's equals negative 15. Sorry, plus. Sorry, that's what I meant. So that one is easily explained. And then plus, we're going to multiply negative 5 times negative 3. And if this is what you didn't know, right, and we're using this to prove why a negative times a negative is a positive, well, just using logic, right, just using common sense, well, negative 5 times negative 3 to keep this equation true can only equal to positive 15. Because then, when you add it to negative 15, it does equal 0. So this, right, kind of proves that a negative times a negative is a positive. All right, 5. Okay, so just 5 is just what do you call substitution, evaluating. So A is negative 2, B is negative 3, C equals negative 4. So let's replace A. So let's do this first one here. And we're going to get that minus sign is already there. Negative 2 times B, which is negative 3, minus C, negative 4 over 2, second power 2. That's what that looks with substitution. So now we have negative, negative, negative. All three negatives here together. So that's obviously is going to give me a negative. 2 times 3 is 6, right? Minus, and then we have negative 4 to the second power, which is positive 16, right? So, and finally, negative 6 minus 16 is negative 22. BC over negative C, so B is negative 3 times C, which is negative 4, over minus, and then that already was there. That has nothing to do with the negative that's incoming right now. So if I replace C, and this is what and how you should have written it. Okay, with substitute. So let's simplify a few things. On the top, negative 3 times negative 4 is positive 12. And then at the bottom, we have a negative and a negative. So that gives me positive 4. Simplify that again. Final answer equals 3. Negative a squared. Okay, so again, think about what you're doing. You're replacing the a with its value. So that negative is already there. And then take the a out, replace it. We got negative 2 to the second power. So that's what it looks like with replacement. Do the exponents first. Negative 2 to the second power is 4. So actually, let me write down negative sign before, and now do this part, which is negative 2 to the second power, and that's 4. Final answer, negative 4. 3c, okay, so 3 times c, which is a negative 4, minus 5, plus b, which is negative 3. All that over a, which is negative 2. Okay. On the top, order of operation dictates I have to do these two, right? Multiply first and then subtract 5 and then add negative 3. Let's do that. So 3 times negative 4, now right over here, is negative 12. Then we're going to do minus 5 plus negative 3. All that over negative 2. Let's continue that. So let's negative 12 minus 5, negative 17. Negative 17 plus negative 3 is negative 20. Divide that by negative 2. And the final answer is going to be positive. C cubed, A cubed. C cubed is negative 4, so put that in parentheses, raised to the third power, minus A cubed, which is negative 2, raised out to the third power. Let's write the exponents in standard notation. Negative 4 times 3. Sorry, negative 4 to the third power is negative 4 times negative 4 times negative 4. So that's going to give me a negative, first of all. 4 times 4 is 16, times 4 is 64. Minus, and then negative 2 to the third power is negative 2 times negative 2 negative times negative 2, which is going to give me negative 8. So that's what our expression in standard notation looks like. Now I can subtract, well, change with an addition if you like, and we get negative 56. Okay. 6, they're asking you if that equation is true. Well, let's do the left side. Okay, so let's do the right side because it's the easy side. So equals absolute value, negative 12 minus 7 is negative 19. And then the absolute value, negative 19 is 19. So on the right side, we get 19. Well, let's see if the left side gives us the same value. Well, that minus sign is going to just hang out a little bit, okay, until we take the absolute value. So again, inside, negative 12 minus 7 is the same thing as the other side. It's still negative 19. The minus sign is here, it's outside. Take the absolute value of negative 19 now, which gives you, so let me write that like that. No, sorry. Take the absolute value of negative 19, which is 19. That minus sign that was outside just comes down, right? So we end up that the left side is negative 19 and the right side is positive 19. Are they equal to each other? Or they're not? Okay, so keep change flip is very popular in 721. Where does it come from? Use the example below to show your explanation. So there's a lot of ways we can prove that, right? So 3/5, let me write it like this, divided by 4/7. So one way of dividing is to divide across. So if I divide 3 divided by 4, I actually get 3/4 over, and if I actually divide, if I divide across, right, 5 divided by 7, I get 5/7. Now I want to get a whole number here, right? So I want to get my denominator to be a whole number, in, what do you call it, a 1. In order to do that, I have to multiply 5/7 to 7/5, which is the reciprocal. And if I do that, guess what? This and this simplifies to 1 and 1. 5 divided by 5 is 1. 5 divided by 5 is 1. So my whole denominator becomes 1, which is something that I want to do. Now, if I multiply the bottom by 7/5, guess what? I have to multiply the top by 7/5. 7/4, sorry. So I actually have to start this again. Apologies. So again, if I multiply across, I end up getting 3/4 over, no, I was right, 5/7, right? And then I multiply by the reciprocal, I get 7/5. And then I multiply the reciprocal on top again, because whatever I do to the denominator, multiply to the numerator. At the bottom, everything simplifies to 1. On the top, I'm going to get 21 over 20. And if I put that over 1, it's not necessary, because so that ends up disappearing. And then I can write 21 over 20 if you want as a mixed number, 1 and 1 over 20. So that's one way. Now the other way, let me just write this bigger, it's 3/5 over 4/7. And again, let's make the denominator, let's change our denominator so that the denominator equals 1. So in order to do that, I can multiply this by 7/4, which is its reciprocal. Again, that all simplifies to a nice 1. So my denominator is 1 already. On the top, I'm going to multiply that by 7/4. And look at that. 3 times 7 is 21. 5 times 4 is 20. All that over 1, which I'm not going to write because it's redundant, not necessary, but I still get the same answer. 1 over 20. But then you notice that by doing this over and over again, what are we exactly doing? So think about it. 3/5 divided by 4/7. What exactly did I just do here? I took 3/5 and multiplied the reciprocal of 7/4, which is 4/7, which is 7/4. And that's why you keep doing this keep, change, flip that you keep mentioning in class. Okay. Oh, and one other thing while I'm at it. If I divide 3/5 and 4/7, what answer did I get? 1 and 1/20. How do you explain this part? Where does 1/20? That would be a good question in the quiz. What is that? Right? Where's that fact? So, can you explain what these two numbers mean? Where does the 1 and 1/20? Yes, it's the answer to your problem here, but what do they represent? So, let me show you this as if you were in my 6th grade class and divided by 4/7. So, one way to really see that is to change both fractions so they have common denominators. So, the 5, I'm going to take it to 35, right? The common name is 35, denominator is 35. So equivalent fraction of 3/5 in 35ths is going to be, well, times, if I multiply this by 7, I multiply this top by 7, so I get 21. So 3 over 3/5 and 21 over 35 are equivalent fractions. 4/7, if I change it, so denominator 35, well, would be times 5. Sorry. And then multiply the top by times 5, and I get 20. Right, so I didn't change anything. I just rewrote 4/7 into an equivalent fraction, which became 20 over 35. So now think about what this is. So if I had something, right, a big chocolate bar, and I showed you that there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 20, 21. So I have all this, and I'm going to highlight this. This is how much chocolate I have. That's 21 pieces. 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, that, whatever. Right? So I know this is 21 over 35. 21 to 35. And then over here, right? again, 35 pieces, except that I'm asking the question, say, how many times can I fit this 20 over 35, right? Because it's just one piece. How many times can 20 over 35 go inside 21 over 35? Well, it can go, this 20 pieces can go inside the 21 pieces one time, right? So if I take the 20 over 35 and put it inside 21, 35, 20 of them will fit in, right? Now if I try again, right? If I try to put the 20 over 35 inside the 21, 35 again, well, first of all, the first 20, right, were used already because I already fit 20 or 35 inside once. And if I try it again, right, how many of the 20 over 35 was I able to fit? Well, I was able to fit one of those in here. So I was successfully one out of the how many times? Out of the 20. Yeah, I used to love doing this in 6th grade. It's so nice because you could actually understand your quotient. Anyways, probably did that last year. 2. Oh, yuck. Sorry, 8. Negative 4/5 minus 8.75 divided by 0.025. Oh, yeah, okay. So I'm going to change this to a decimal. That's 2.8. Minus, I'm going to divide these two. Is there an easier way to divide these two? Well, 8.75, right, let me write as a fraction, and then 0.025. What if I multiply the bottom by 1,000 and the top by 1,000? I multiply both by 1,000 means a decimal place, right? That moves to the right 3 times. So if I move this to the right 1, 2, 3, my denominator becomes 25, yay. And then my numerator is going to be 1, 2, 3, and that empty space I added a 0, so that becomes 8,750. Much prettier to look at, right? Now, if you want, you can go ahead and actually do your long division. 25, it would be 3, 75, 1, 12, 25, and that would be a 5, which is 125. Bring the 0 down. So that would be 350. So 8.75 divided by 0.025 is 350. Minus negative 4 to the 3rd power is a negative times a negative times a negative. Still going to be a negative, but negative 64. I can finally add and subtract this. Negative 2.8 minus 350. It's the same thing as 2.8 plus negative 350. And I'm going to do, well, I like to do those first. So we're adding 2 negatives. We're going further to the left-hand number line. It gives me negative 352.8. Then minus negative 64, which to be honest, I could have automatically just changed it to plus 64. So now negative 352 and 8/10 plus 64. Right? So the absolute value of this guy here is definitely bigger. So we know that my answer is going to be negative because from this absolute value, I'm going to take 64. So 352.8, from that I'm going to take 64, and that's going to leave me with 288.8. If I did it correctly. Alright, bottom 2, hopefully these two are a little bit more challenging than the ones you did in class because we're at lunchtime. Let's do the first one. So first difference, what is this? 3, 5, 7, 9, which is not linear, right? So we take the second difference. It's 2 plus 2 plus 2. What do we do with that 2? We have it. So 2 divided by 2 equals 1. And we know it's an n square sequence. So so I know my answer is already that much. What's an n squared sequence look like? Well, substitute the first 5 numbers. When n equals 1, it's 1 squared. 2 is 2 squared, which is 4, 3 squared, which is 9, and 16, and 25. So our next step is to remove this sequence from the original sequence. So subtract 11 minus 1, 14 minus 4, 19 minus 9. So look, it's all 10, 26, well, 10, and 10. So this one's actually easy. Now, look at what's left over here. Okay, that's not a sequence. Right? If you took the first sequence, first difference here would be 0, 0, 0, 0. So that's not really a sequence. So that means that our nth term here, it's an n squared sequence, but with a slight adjustment of 10. So if you think about it, look at our fifth number has to be 35. Well, if I substitute 5 over here, I get 5 squared plus 10. 5 squared is 25 plus 10 gives me 35. Look at that, it works. My third term is 19, so let me substitute 3 over there. Well, I get 3 squared plus 10. 3 squared is 9, and then plus 10 gives me 19. So this appears to work. Now, and the reason we stopped over here is because when I take the first difference, it's 0, 0, 0, 0. So that's not really a sequence here, a linear sequence. Okay. Let's try the next one. Plus 6, first difference. Yeah, plus 10, plus 14, plus 16. Okay, so that's not linear. There's a quadratic sequence in there. So we'll take the second difference. Looks like it's plus 4, plus 4, plus 4. Take that 4 divided by 2. Our coefficient is 2. So over here, I'm going to put 2n squared. That's what our first step is. Now, what's a 2n squared sequence look like? Substitute, plug in 1, 2, 3, 4, and 5 in here. Find the first 5 terms of an n squared sequence. So it'd be 1 squared, which is times 2 is 2. 2 squared is 4 times 2 is 8. 3 squared is 9 times 2 is 18. 4 squared is 16 times 2 is 32. And then, oh no, not another one. Oh. And then 5 squared is 25 times 2 is 50. So if I subtract, why don't I give you the easy ones? 2 minus 2 is 0, that's 0, that's 0, that's 0, that's 0. So guess what? That's your sequence right there. There's nothing left over. There's not another sequence, a linear sequence inside of here. So it's just this. Well, let's see if that works. 2n squared. The fifth term is 50. So if I plug in 5 over here, do I get 50? 2 times 5 squared. 5 squared is 25 times 2. I get 50. Oh, yuck. Okay. Yeah, well, it is that easy. Okay. So it works. And then plug in another number. Let's say the second term. The second term should give me 8. If I plug in 2, I get 2 times 2 squared. 2 squared is 4, and then times 2 is 8. Look, it works. So this is my nth term. So this I can use to find any term in that sequence. Thinking. When finding the second difference, why do we have the difference when finding the nth term? Well, okay, so remember I said in class. So the quadratic sequences are in this format. Right? So then, well, let's see what. Let's plug in 1 and find what the first term is in this sequence. If I plug in 1, when n equals 1, I'm going to get a times 1 squared, which is a, plus b times 1, which is b, and then plus c. When n equals 2, what do I get? Well, plug it in here, right? So it's 2 squared, 2 squared is 4, I get 4a, plus, and then 2 times b, I get 2b, plus c. N equals 3, I'm going to get 3 squared is 9, so I'm going to get 9a, plus 3b, plus c, and then we'll do one more. When n equals 4, I get 16a, plus, what is that? 4b, plus c. Now, let's take the first difference. how does this get to this? Or what's 4a plus 2b plus c minus 3a plus b plus c? So you can subtract, or like I said, how do I get from a plus b plus c to 4a plus 2b plus c? Well, we add 3a, right? So a plus 3a would give me 4a. And b plus what would give me 2b would be b. And then I don't need to add a c. So that's the first difference for these two, between these two numbers. Second one, find the difference. How does 4a become 9a? Well, you add 5a. How does 2b become 3? Well, you add a b. And the c, well, we don't add anything. And then here we get 9a to 16a is 7a plus b. Okay. Well, because we're doing quadratic, we have to take a second difference, right? So how do we get from 3a plus b to 5a plus b? We add 2a. How do we get 5a plus b to 7a plus b? We get 2a. So notice that I need this to be this. Okay, I need this 2a to somehow become this a. And in order to do that, the only way I can do that is to, well, is to divide that 2 by 2. And if I divide the 2 by 2, I get a coefficient of 1, which is, sorry, coefficient 1, which is what is in here. Okay, or just a, apologies. Okay, so in order for the 2a to become an a, I divide the 2a by 2. And that's the reason why we have it. Okay. And then you have your culminating. Be careful there. Okay, so I'm just going to do an example here. I'm making up my own, just in case anybody's still watching. Let me make that 0. Let me make this, I don't know, let's make that 2, and let's make this b. And let's do 2 minus b. Just making this up. Because it doesn't matter what it is, it's, again, the idea is the same. So let's identify what we have here. So 2 minus b, and I want to identify by the actual size. So 2, this 2 over here is this, right? This size here. So that's 2. Let's call that 2. About. And I'm going to put a 2 because that's the value, right? That's the value of this size, the magnitude of this particular part. And it's a positive number because it's to the right of 0. And then they're telling us that we want to subtract, and here's my minus sign, b. Let me take b. B is very tiny. Okay, I'll put that, that's b. And as of now, that b is negative. So that's the size of b, and b is a negative number, okay, of this size. Well, don't start explaining anything yet. Let's change this to addition. So this is going to stay the same, right? Same size, it's still positive, but subtraction is going to be addition. And this, the size is going to be the same, right? Still the same size, that's still b, but b now will be positive. So when they ask you, is 2 minus b a positive, a negative, or 0? Don't answer that right off the bat. Answer it at this point when you're ready to answer. Well, it's a positive plus a positive. Well, what does that mean? What am I doing with this absolute value? With this, what am I doing with this? Am I doing this? So again, you have two choices. 2, and then let me add the little b, right? So now the answer is the sum of those two absolute values. Or am I doing this? Here's 2, and I'm going to change colors, the little b here. Or am I removing this b from this guy here? Am I taking that out? Right? Well, obviously, the answer is this one, because they're both positive. I'm combining both absolute values, right? I'm combining their two distances together. Okay, so the answer to this one is definitely positive. Okay, so you got two choices. You're either going to be combining their absolute values, right, and making it a longer piece, or you're going to take the smaller piece from the bigger one, right? And the sign will be of the one with the greater absolute value. You know what? While I'm doing this, why don't we do one of those? So another problem. Let's call this B, and let's call this 1. So let's do B minus 1. Okay. Now let's do B plus 1. Sorry, let's do that. Okay, so if one of the questions on that common negative was B plus 1, is the answer positive, negative, or 0? Well, again, before you answer that question, draw it up. So let's draw B up. B is about this size. I'm doing it right under it, so I precise. So that's B, the size of B, the absolute value of B, and it's negative. And they're telling us to that, they said, please add 1. Well, 1 is from here to here, so let me try to, as best as I can, draw it. And that's 1, and 1 is a positive number. Okay? So, I'm adding a negative to a positive. Think about what that means. Right? So, it looks like the negative here, the B, the absolute value is greater than the positive. So, let me put this inside. So, one way, imagine we had 8 negatives, right? So let's say this was B, and I'm just making this up. And the positive was 1, or however it was. All I know is that the positive had a smaller absolute value. Well, can we make 0 pairs? Yeah, this and this would be 0, 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 this and this would be 0. What am I left over with? I'm left over with a negative value, right? So you get the idea, right? I'm just using an example. I know that the negatives have a bigger absolute value than the positives. So what am I doing with the two absolute values? Is my answer going to be this, which is the B, which is negative, and next to it I'm going to be putting the 1, the absolute value of 1, right? The distance of 1 from 0. And that's my answer, those two absolute values combined together. Am I doing that? Or, and am I going to do this? Here's B, which is a negative. And let me draw the 1, which is a positive number. Or from the bigger absolute value, am I coming here and measuring what 1 is exactly? And let me change colors. Or am I removing this part up to here? Whatever, right? Am I taking this away? So whatever 1 is, I'm putting this on top, right? And removing the 1. And then this left over is my answer. Right? So from the bigger absolute value, what did I remove? I removed this piece, right? I took that and I took this piece out. And my answer is negative because the B has a greater absolute value, right? You always take the sign of the one with a greater absolute value. Right, think about this on number, and again, let me draw another number line. So it says B plus 1, right? That's what we're doing, B plus 1. So if you're at 0, it says B plus 1. So the first thing you have to do is walk to B. Done. Right? This distance right here. You're at 0, you walk to B. You just walk B. And then you're adding a positive. What does adding a positive mean? Well, at the end here, from near the end, you're going to add 1. Well, adding a positive, means that you always go right on the number line. So I'm going to walk how far back, how much to the right am I walking? I'm walking the value of 1, this distance right here. Right? So where's my answer? My answer is this part right here. Well, think about a situation. I went and I asked Miles for B dollars. I went and I spent it on the PTA store downstairs, right? But guess what? After I ate all the cookies and chips, I am negative, and that's what B represents. I'm in a negative situation right now. Okay? And then somebody felt sorry for me because they didn't want me to owe money, and they helped me out. They gave me $1. They said, "Don't have to pay me back. Take this dollars and take this money, and go pay Miles." Guess what? I did pay him back, but I still owe him a little bit more. But nevertheless, I'm in a better situation now than I was before. That's another way of looking at it. Okay, that's it.